Alright guys, Algebra 2, lesson 27.4, seniors, you only got one more video after this. Woohoo! Alright, well I hope you've downloaded Desmos, alright, on your cell phone, and I hope you've been so bored that you've kind of played around with it, okay? Because if you play around with it, this really can help you out with understanding how to do these graphs. Ooh, something just popped in my head. You can change the graph paper when you're doing Desmos, and you click on this wrench on the top right, and if you click on the wrench, see, you can change it from radians to degrees, and then not only can you do that, but you can change the x-axis range. I did from 0 to 720, and I did steps up 90 degrees, and then the y-axis I just did from -8 to 8. So if you click on that wrench, you can toggle between degrees and radians, and then you can really get accustomed to it if you do it that way, okay? All right, so today what I thought we would do is I'm gonna type in stuff, okay? I think I'll just do 4 different ones, and I want you to try to guess what the graph will look like, and then also how the numbers affect the amplitude and how it affects the period, okay? All right, so the first one I'm going to graph y equals sine of x, and before I type in that x, can you kind of guess, or can you type it in on Desmos and see if you get the same red graph, okay? And then take a look at here. I'm just doing from 0 degrees to 720. I'm just kind of showing you, look, when it's just plain old sine of x, every 360, the period of time is 360, that pattern's going to repeat, okay? Let's check the values. When you're at 0 on the circle, the sine of 0 is 0. When you're at 90 degrees, the sine is 1. When you're at 180, you're back at 0. When you're at 270, -1. And then remember, when you get to 360 degrees, you're back to the same answer, 0, which is also 0. Okay? All right, everybody's cool with the red graph? That's y equals sine of x. Okay, so I'm going to type in the next color, and I want you to guess before it pops up, I guess. So what would happen if I put a 5 in front of sine of x? Yeah. Okay, so we're going to do y equals 5 of sine x. So before I hit that x, okay, take a moment. What would that 5 do? All right, here we go. Oh, very cool. Take a look at that pretty blue graph. Okay, look, 0 is still 0 for blue and red, but look, remember how the highest point was 1 for the red? Now that I slid that 5 in front of the trig function, now it jumps up to 5. And look, the lowest was -1, now the lowest one is -5. Okay, so this affects the amplitude, okay? And the amplitude would be 5. Okay, everybody cool with me on that? Highest value is going to be 5, lowest value is going to be -5. Okay, cool. So we'll just compare the red graph, which is y equals sine of x, to the different blue graphs that I'm going to put up here. Okay? All right, let me erase that. Amplitude is 5. Yeah. Let's do, let me not say it. I'm just going to back up, and then you guys can tell me what it's going to be. All right, so in blue, what if we do sine, okay? And yeah, let's just put the coefficient on the x. Before I enter that, can you kind of get an idea how it's going to change that red graph? Okay, here we go. I'm going to put the x. Okay. Oh, wow. So you had this spring, right? This red spring, and you squished it together, so it changed the period of time. And I'm trying to remember period of time. Oh, yeah. Period of time is take 360 degrees and divide by the coefficient of x. All right, and when you divide, you're going to get 120 degrees. So should be repeating every 120 degrees. Let's take a look. Here's your point. We're looking at the blue graph now. Look, you're at 0, you're at 1, you're at 0, you're at -1, and look at that, baby, you're back at 0. And I don't know if you can tell, okay, but right there, that would be 120 degrees. Okay, every 120 degrees, look, boom, 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 and the pattern keeps continuing on, okay? The next one would be 240, and 240 is right there, okay? Excellent, excellent, excellent. All right, so on this last one, yeah, I know what I want to do. We're still comparing it to y equals sine of x. I think something else might have just popped in my head too. But let's just try, yeah, maybe we'll do a fourth one. I don't know. Here we go. What if we change both numbers? So let's do 2 sine, and then we will do, just in case, I'll do parentheses. I don't know if I gotta do parentheses, we're gonna find out. X divided by 4, and yeah, let's try that. Okay, and then we do one more set of parentheses. I'm gonna arrow over maybe. There we go. Okay, let me make sure that I did it right. Okay, I've never typed it in like that. I don't like having that little extra missing thing there, so let's just make sure it's right. Okay, I'm gonna erase all of that. Okay, let's do the easy part. Okay, this 2 would affect the amplitude, right? So the blue one, the highest point should be 2, and the lowest point should be -2. Okay, cool, we're good there. Look, highest point is 2. And then way over there, the lowest point will be -2. But I want to make sure that period is going to be right, okay? So really what that is the same thing as y equals 2 sine of 1/4 x. That's the same thing, okay? All right, so I would take 360 to get the period of time, and I would divide by 1/4, okay? And then 1/4, that would be what? 360 times 4, right? Remember when you divide by a fraction, you gotta multiply by the reciprocal, all right? And then so you're just doing 360 degrees times 4, and so it's gonna repeat every 1440, okay? Every 1440 degrees, the pattern is gonna repeat, and if you look, 720 is only half, okay? So I'll tell you what, remember how I was telling you how you can change the graph paper? Let's do that. Let's go ahead and let's come up here to that wrench, okay? And let's do it. See how I had it from 0 to 720? Let's now do it 0 to 1440, okay? And then now we back away so y'all can see it, all right? 0 to 1440, I got it going, yes I do. Okay, you ready? And then we're gonna count our points, right? So our first point for sine of 0 is gonna be 0. All right, then when you get to 360, you're at 1, okay? Then when you're at 720, you're at 0. All right, then when you're at 1080, you're at -2. And then finally, look, 1440, you return to your very first value, which is 0. So that spring, you have really, the blue spring, you have really stretched it out, all right? And that period of time doesn't repeat until 1,440 degrees, every 1440 degrees. Well, that's hard to say. Okay, I hope this worked. No, I got one more idea. What if I get rid of the blue one and we change this into radians? Yeah. So I'm gonna get rid of the blue one, okay? I got this. Get rid of the blue one. And since we've been playing around with that wrench, changing the graph paper, let's change the graph paper again, okay? So I'm gonna hit wrench, all right? Let's just do one period of time, just for sine of x, which would be 360, okay? So let's just do that first. And I probably should have done that originally, because that makes the graph really easy to see. Okay, so there is y equals sine of x in red. I've got a period of 360 degrees, and you see your values, 0, 1, 0, -1, 0, and of course, the 0, 90, 180, 270, 360. Now let's just change it to radians. This will be a good way for you to see radian action. So now all I gotta do, supposedly, is click on radians. Oh Lord, oh Lord. And I guess I need to change something else. Boy, that certainly didn't work out. All right, so let's take a look. X-axis. We would need to do it in terms of radians. Huh. So let's just figure out what 2 pi is. All right, 2 pi would be what, like 6.28? All right. Ah, there we go. Because remember how in radians, 2 pi is a full revolution. Well, so look what I did over there, okay? It's 6.28 is the same thing as 2 times pi. And then for the increments, you know, you're going to do 3.14 divided by 2. So you do increments of 1.57. And let's just see if that looks better. I'm trying to make this as pretty as possible. And at the same time, I'm hoping I'm making sense. Let's take a look. Ah, dude, check that out, okay? So here you go. You know this is 0. We're talking about radians. And look, this is 3.14 divided by 2, okay? This is pi, okay? This is 3 pi over 2. And then you're finally back to 2 pi, which is 3.14 double. Okay, notice the answers are the same. The only thing difference is we've got the x-axis in terms of radians. Well, hey, I hope this helps. And guys, whatever you do, please take it easy. Seniors, one more video.